Welcome back everyone. So this is a video on the Panasonic PAC Checker. It is used for VRFs or split systems. So this is the unit itself. It's just a little small box. It has a connection on it, pink and blue cable that gets wired into the transmission. So it's U1, U2, whether it be wired into the indoors or the outdoor. And then it's just a printer cable into the laptop. And then it's ready to go. So the software is available for free on the Panasonic Pro Club. This is just an icon of the software itself. It's called Line Checker. So this is the software itself. It's all on one page, so there's no having to switch between tabs. The top half is all indoor information and the bottom half is all outdoor information, so I'll go into a bit more detail on them now. So the top line is just the outdoor model and the software version. So if we go from left to right for the indoor information, so first we have the indoor unit address, then we have the capacity of the unit, next is the model type. OPR is the operational state, so on or off. Next we have the mode, then we have the load level, which is 0 to 30. DIF is the difference between the set temp and the room temp. Then we have the suction temperature of the indoor. Next we have the discharge temperature of the indoor. Then the E's are the coil temps, so E1 is your liquid line and E3 is the gas line of the indoor. If it has an E2, it's just the middle of the coil. Next we have FM, which is the fan motor speed. Then MOV step is the expansion valve on the unit. So that goes from 0 to 480 pulses. Next we have, it's the SVK box, solenoid valve kit. So the valves are discharge, suction, balance and evap temp control. So in heating, only the discharge will open, and in cooling, S, B and E will open. And the last box is an alarm box. If any alarm is present, it'll just be flashing. So this is the outdoor section. So if you focus on the left hand box first, so DC1, DC2, they're the discharge temperature of the compressor. Then we have the outdoor temperature. HP temp is the saturation temperature of high pressure. LP temp is the saturation temp of the low pressure. SC temp is the suction temperature read before the accumulator. Then HE gas 1, HE liquid 1, they and number 2, they are the four-way valves of the outdoor unit. So they'll be sending the gas to the condenser. So they will change, which I'll explain in the full readout. Then we have the oil temp. Next we have the compressor amps. TRG HP is the target horsepower of the outdoor unit. Then we have the target heat exchanger temp. Next we have the pressure readings. So it's obviously high pressure, low pressure. That's read in MPa. So 192 there would be 19 bar. Next we have the oil level, so that either reads 0, 1 or 2. 2 is fine. 1 is it needs to be topped up and 0 is it's basically empty. Next we have the alarm box. If there's an active alarm, that'll be flashing, so it'll be PO5 for argument's sake, or EO1, etc. Then the info is for a pre-trip, so this is for inverter issues. So you'll have maybe P26, P19, they'll be flashing in there, but it won't be an active alarm on the system, it'll just have a warning triangle on the indoor remote controllers. So the right hand box starts with the inverter hertz, and then the rest are basically all the different valves in the outdoor. So rather than go through them all, I'm just going to attach a screen cap that just explains all the outdoor valves that are in operation there. So this is a system that's obviously here you can see in full cooling. So on a maintenance, what I would be checking is obviously the E1s and E3 temperatures. So you can see all the E1s are in and around 5 degrees, which is perfect. Our compressor discharge is 77 again, which is fine. Our pressures are 19 and 5 bar again, which is fine. So then the last thing I would be overly concerned about would be the four-way valves. So HE gas 1, HE liquid 1 and HE gas 2, HE liquid 2, they have to kind of match, not like for like, but they have to be very similar to each other. So when the system isn't cooling, these valves should be heating and sending the hot gas up to the condenser. I'm going to attach a screen cap now of a system that was in full cooling mode, and you can see that one of the valves is stuck. So you'll see that one of them appears to be heating, one of them appears to be cooling, but they're both being called for in a full cooling mode. So I'll attach that now so you can get an idea. So you can see here SCV number 2 is stuck on this system. It's sending cool gas up to the condenser when it obviously should be sending hot gas because it's in full cooling mode. But one thing to note as well, on the right hand box, DCV 1, 2 and 3, they ultimately control the flow into the 4-way valve. So you just have to make sure that they're on or off, obviously depending on the mode, because it may appear that one of the valves is stuck, but if you look across, the valve just might not be being called for. So that's definitely something to keep an eye out for. So this is our system in a full heating mode. So again, it would just be the same checks that I would carry out in heating mode as I would for a cooling mode. So firstly, we can see the E3s, they're all a very good temperature. Next, I would have a look at the pressure. Again, it's 27 and 7 bar, which is well within range. Our 4-way valves are good, all of them are fully cool in there. Our inverter compressor is running. That's another thing you could look out for. If that's constantly reading 0, I would be checking the outdoor to see whether it's in backup. But as you can see, everything looks good on this system. So hopefully this video has given you a bit of an insight into the use of the PAC Checker. As I said at the start, the software is available for free on the Panasonic Pro Club. And if anyone has any questions, just leave some comments below.